Hello, folks. Day 7 of our derivative unit. It's totally not Unit 5. I was trying to write HPC as honors pre-calculus and then Unit 5, Day 7, but we're not even in Unit 5. So I pretty much just failed at that. We are in Unit 4. My geometry class is in Unit 5. And I just planned their lesson. So I was confuzzled. My bad. Unit 5, differentiation. I've been talking a lot about tangent lines. We're going to look at a few variations on that problem today. So let's get started. Okay, so we're going to start it off here with our classic tangent line problem. We're given a function, and we want to write the equation of the tangent line to that function f of x at the x value of 3. Problem is, this function is in factored form, and as of yet, we do not know how to take the derivative of a function in factored form. So I'm going to start by expanding this value x minus 1 quantity squared to get x squared minus 2x plus 1. Check yourself on that. You should end up with that. So we want to write the equation of the tangent line. So remember, to write the equation of a linear function, we need to know two things. We need to know a point, and we need to know the slope. So the point that we need to know is going to be the point of tangency, the point that is shared between the function and the tangent line. And the thing is, we know the x value that we're looking at is 3, and we have the equation of the function right here. So let's plug our point into our function to figure out the y value when x is 3. So I'm going to plug in 3, get 3 minus 1 squared. 3 minus 1 is 2, squared is 4. So I have my point. I know that the point x is 3, comma y is 4. It has to be on the function, and it also has to be on the tangent line. So now that I have my point, I need the other thing. I need my slope. Now, to find the slope, we need to take the derivative of this function. So the derivative, f prime of x, of the function x squared minus 2x plus 1 is going to simply be 2x minus 2. We're using the power rule. We multiply the power by the coefficient, subtract 1 from the power, so then it becomes 1. And we do the same thing here. It was 1 there, so we multiply by that. We get the negative 2, and we drop it to 0. Whoa, 0, that's a 0, so it goes away. And a derivative of a constant term is always 0. So we end up with our 2x minus 2 as the derivative function. And we're looking at the x value of 3, so we need to plug that in. 2 times 3 minus 2 is 6, minus 2 is 4. So again, what does this represent? Well, this 4 is the value of the derivative at the x value of 3, which is the slope of the tangent line at x equals 3. So I can write this equation in point slope form and get y minus 4, the y value of my point, equals my slope, which is 4 times x minus 3. And I am done. You can always check yourself. Sketch this function on your calculator, graph it on your calculator, and calculate the tangent line there. Do the draw feature to draw the tangent line. And compare it to this equation. If you rewrite this in slope-intercept form, y equals 4 times x is 4x. 4 times negative 3 is negative 12. And then I'm going to be adding 4 to that to bring that negative 4 over. So we get y equals 4x plus, just kidding, minus 8. And draw the tangent line at the x value of 3 on your calculator, and you should get the same thing. So now we're going to do another tangent line problem, but we're going to do something kind of weird. Notice that I have the same f of x function over here as for the previous problem. But now I'm defining g of x to be the inverse of the function f. That is weird. Remember what we know about inverses. We know that inverse functions are reflections over the line y equals x. We know that that is true because the x and y value of every single point becomes swapped. And furthermore, we can use that fact to write the inverse of a function by writing the original function y equals x minus 1 squared, and then swapping x and y, x equals parentheses y minus 1 squared, swapping x and y, and then solving the equation for y. Because think of what we said, you literally swap x and y. So flip them and solve this. So we need to take the square root of both sides. So we get the square root of x equals y minus 1. And then we're going to add 1 to both sides. So we get the square root of x equals, just kidding, it's very late, square root of x plus 1 equals y. So we are saying that g of x equals the square root of x. I don't even remember what it was. It was a plus 1, minus 1, plus 1. Okay, square root of x plus 1. And let's close off that g. And now I am going to erase that work so I can see better. Okay, so now we have g of x, the inverse function, and we want to find the tangent line to the inverse function when x is equal to 4. So we're going to do the same exact thing, but on this function g of x. So we need two things. We need a point, and we need a slope. So we have the x value is 4, and we want to find the y value. So let's plug that into our function. Find g of 4 is going to be the square root of 4 plus 1 is 2 plus 1 is 3. So that tells me I have the point 4, comma 3. Hey, that's kind of weird. On the last problem that we did, I had the point 3, comma 4, and then on the inverse, we're having the point 4, comma 3. Wow, that was a really weird sentence that I just tried to say. I was trying to be clever. I was trying to show you that the point was just flipped because it's the inverse, so we swapped the x and y values. But then it just came out weird, and now I'm rambling. So let's keep going. What do we do now? We have our point, so now we need to find our slope. So we need to take the derivative, g prime of x. So g prime of x using the power rule. Well, first off, remember that we need to write this as x to the 1/2 plus 1. That way we can use the power rule, multiply 1/2 out in front of that function. So we're going to get 1/2 times x to the power of negative 1/2, because you need to subtract 1 from your exponent. Derivative of a constant term is 0, so the 1 just goes away. And now I'm going to rewrite this a little more professionally as 1 over 2 times the square root of x, because the negative exponent means move it down, and the 1/2 exponent means take the square root. So we're almost done now, but we need to plug in the x value of 4 so that we can find our slope. So let's plug in the x value of 4. Let's find g prime of 4 equals 1 over 2 times the square root of 4. 1 over square root of 4. Square root of 4 is 2. 2 times 2 is 4, so we get 1 over 4. And again, that is our slope. So now we can write our equation in point slope form. Y minus y1, so the y value of the point is 3, equals our slope, which is 1/4, times, in parentheses, x minus 4. But as before, we want to check ourselves on the calculator. So let's solve this for y. and we will get y equals 1/4 x. Distribute in the 1/4 to the negative 4, we get minus 1. Add another 3, and we get plus 4. Except for the fact that I can't count, and negative 1 is what we get when we distribute the 1/4 to the negative 4. And if we add 3 to get the negative 3 out of the other side, we get negative 1 plus 3, which is a 2. So there is that function. So I don't remember where I left off that sentence, but I want to point this out to you because it's just pretty cool. So in the top there, we have the tangent line from the inverse function, and in the bottom, we have the tangent line from the original function, both written in point-slope form. Look how cool those are. Look, the 3 in the y and the x, those trade places, and then the 4 in the other y and the other x change places. And then in the middle there, not that color, I guess this color, in the middle there, our slopes are reciprocals of each other. That is nuts. Okay, so now let's graph all of these together because it's going to be really cool to look at what this is going to look like. So notice first, well, just graph all these functions and then we'll talk about them. And put in that window, and then if you hit zoom and do option number 5 for z square, that is the best thing to hit after defining a window if you want to look at something like 2 inverses. So if you graph all these things, you get this. And our blue function is the original f of x function. The red function is the inverse of x that we graphed. But here's the deal. Remember, if we took the square root, really you're taking the positive square root and the negative square root. So red is representing the principal square root, and then black is representing the negative square root. So both of those are right there. And what I just wrote is actually strictly not true, but it's not negative f inverse of x, but I'm saying it's the non-principal square root of that one. Okay, and then look in the middle, we just have the line y equals x. And then finally, the green function is the tangent line to f of x. So that tangent line right there. And then the purple function or pink function, whatever that is the tangent line to the red function, the inverse. So, some things to point out again. Notice that the point of tangency there is the intersection point where all 4 of these lines meet. So this point right here. Folks, I am a huge liar. I am so exhausted. It's 11:45 right now on a Tuesday night, and I should be going to sleep, but I'm not. I'm making these videos. What mistake did I make? Maybe you caught it. First off, the mistake was choosing this graph because I thought it looked cool, but now I'm realizing that it looks like a creepy clown or something, or like it almost looks like a creepy Elmo. So I don't think I should have done this. Wow, that's like surprisingly creepy. So let's undo all of that. But I need to correct this. I said that intersection point in the middle was where all those lines intersected. That is not true. Why is that not true? It's not true because on the red function there, the tangent point had an x value of 1, 2, 3, 4, and a y value of 3. So that is the point of tangency there. And then on the blue function, the point of tangency had an x value of 3 and a y value of 4. So there you have that right there. But it is still a very interesting graph. Tons of really interesting symmetry there. Remember that these slopes were reciprocals of each other. And notice also that the points we looked at were 4, 3 and 3, 4. All of this having to do with inverses. If you want to figure out a relationship between a function and the derivative of its inverse, crazy things happen. You can check it out. It's cool. But let's move forward. Let's make some progress. Let's look at a couple other types of problems. So we want to find k such that the line is tangent to the graph of the function. So we got to remember the two same things as before. Ooh, that's too big. Same two things as before. We need the point and we need the slope. So to find the point, remember that it is the point of tangency, where the tangent line and the function both share that point. So I can set the function equal to the tangent line and get x squared minus kx equals 4x minus 9. And I can write the equation, what I need to know about slope. Think about, again, the derivative of a function at a specific x value tells you the equation, the slope of the tangent line at that x value. So if I take the derivative f prime of x, using the power rule, I'm going to get 2x minus k. And that has to be equal to the slope of the tangent line function. So that has to be equal to 4. So now I'm going to solve this second slope equation for k. So I'm going to get 2x minus 4 equals k. And now I'm going to take this whole expression for k, and I'm going to substitute it into this equation right here. So I'm going to get x squared minus k, which is in parentheses, 2x minus 4, close my parentheses, times x equals 4x minus 9. Let's solve this system. So we need to distribute and combine like terms and stuff. So I'm going to throw in that x into those parentheses. So I'm going to get x squared minus 2x squared. Notice I'm also going to distribute in that negative. Whoa, crazy. I'm going to get x times a negative 4 gives me a negative 4x. Distribute in that negative to it, though. Becomes a positive 4x equals 4x minus 9. So notice 4x and 4x will eliminate with each other because I can subtract that from both sides. And I get x squared minus 2x squared. I should probably combine those now. X squared minus 2x squared is negative x squared. Can't do math anymore. You guys feel that way sometimes? Nah, I bet you never do. Negative x squared equals negative 9. So x squared equals 9. So x equals 3. So as always, once we find one of these values, we need to plug in to our other equation to find the other value, k. So k is going to equal 2 times 3 minus 4 equals 6 minus 4 equals 2. So we should probably finish this up then by saying f of x equals x squared minus 2x. And so then you could graph this on your calculator, and it's going to look something like that, except the line's actually going to be tangent, so they're going to share a point right there. And I would recommend you check this by graphing the function x squared minus 2x and drawing the tangent line at the x value of 3, because then it will tell you the equation y equals 4x minus 9, just like we knew we were starting with. But then there's this crazy little thing called math that says when you take the square root of a number, you actually end up with a positive solution, that's a plus sign, and a negative solution. So when we took the principal square root, we ended up with this function. Let's see what happens when you use the other solution, the negative solution. Whoa, I'm so tired. Okay, well, again, what do? We're going to plug it in to k right there. So now we're going x is negative 3. Plug it in, we get 2 times negative 3 minus 4 equals k. And so we get k equals negative 10. So then when we plug that into our function, we're going to get f of x equals x squared plus 10x, because k is negative 10 and it's minus kx. And so if you graph this function, then you end up with something that looks like this. And when you take the derivative at the x value of negative 3, more over there, you indeed do get the equation y equals 4x minus 9. So this problem had 2 solutions. That's awesome. So let's do another problem of the same variety. First, though, I'm going to rewrite this function as k times x to the negative first. Find k such that the line is tangent to the graph of the function. So notice negative 3/4 is my slope m. Let's go ahead and do the same thing as before, and let's find the derivative g prime of x. So using the power rule, I'm going to get negative k times x to the negative second is negative k over x squared is my g prime of x function. And I need g prime of my x value, whatever it is, to equal my slope at that x value, m. So I need negative k over x squared to equal negative 3 over 4. And I'm going to leave that for now, and let's see what my other function is going to be. This time I'm going to get this function by setting my two equations equal to each other. So I get k over x equals negative 3 over 4x plus 3. And so let's start to solve this. I'm going to do something crazy here when I solve this. I am going to multiply by 1 power of x on both sides of my pink equation. So I am going to get, well, let's do this first. And also notice I have a negative and a negative, giving me positives. So if I multiply by negative 1 on both sides. So now I'm going to multiply by x on both sides to get k over x equals 3x over 4. Maybe you see why I did that. Oh, hey, look, k over x and k over x. So I can set these two branches equal to each other. So I get 3x over 4 equals negative 3 over 4x plus 3. Well, 3 over 4x equals negative 3 over 4x. If I add a 3 over 4x to both sides, I am going to get 2 times 3 over 4x. So I'm going to get 6 over 4x. 6 over 4 times x equals 3. So do a little more algebra. Multiply by 4 on both sides, divide by 6. Or simplify that first, multiply by 2 on both sides, divide by 3. Let's do that instead, because what I'm saying is 6/4 is the same as 3 over 2. 3 over 2. Oh my god, I'm talking like that con dude. I'm repeating myself. Now, let's see what we can do. We're going to divide by 3 and multiply by 2. 3 over 3 is 1, so I get x equals 2. And what do I do with that now? I know that x equals 2, but I still need to find k. So I'm going to plug into one of my equations. So look at this one right here. K over x equals 3x over 4. So I'm now going to move that other x up as well to get k equals 3x squared over 4. I'm going to plug in my x value to get 3 over 4 times 2 squared, which is 4. 4 over 4 is 1. So k is 3. And again, check this on your calculator. There's absolutely nothing different about this question. Find the equation of the line that is tangent to f of x and parallel to g of x. We don't care that it's parallel to g of x and not actually the tangent, because all we care about is the slope. So, boom, boom, boom. I know my slope is 4. I have my function there. I need to figure out when this function has a derivative that is equal to 4. So let's think about how I can do that. I need to take the derivative. So f prime of x equals, power rule says, multiplied by 2. So I get 2 over 2, so that goes away. And I drop the power down by 1. So I'm going to get x minus 3x becomes 3 for that derivative. So I need to know when is uh, x minus 3 equal to 4? Because again, I need my derivative to equal the slope of 4. So 4 equals x minus 3. Add 3 to both sides. 7 equals x. So now we need to write the equation. So I have my x value, need my y value, plug into my function. So 7 squared over 2 minus 3 times 7 gives me 49 halves. Then I have to subtract 3 times 7 is, whoa, my pen changed colors. 3 times 7 is 21. But instead of writing 21, I am going to double it and write 42 over 2. 21 times 2 is 42. So I have a common denominator. So I can say y is 49 minus 42 is 7 over 2. So then I can write my equation, y minus 7 halves equals my slope, which is 4, times x minus 7. And let's go ahead and write this in slope-intercept form so we can check our work on the calculator. Y equals 4x minus 7 plus 7 halves. So I'm going to rewrite 7 as 14 over 2. So I can get y equals 4x minus 14 minus 7 gives me negative 21 over 2. So your calculator would tell it to you as 4x minus 21 divided by 2 is 10.5. But it'll probably give you a bunch of zeros. So, do you remember that part where I said it's really late and I can no longer do math? Yeah, I was not joking. I goofed up. I forgot to distribute my 4 into my 7 there, so that should be minus 28 plus 7 halves. So then if I double 28, I am going to get some number, like maybe 56, I think, over 2 plus 7 over 2. So 56 plus 7, but oh my gosh, it's not 56, it's negative 56 over 2 plus 7 over 2. This is like the worst explanation ever, my bad. So we're gonna get negative 49 over 2, which is gonna be negative 24.5. When you do it on your calculator, that should be correct this time. So let's do this one last problem real quick. Find the equation of the two tangent lines to f of x that are perpendicular to g of x. After we do this one, we can all go to sleep. because it's super late, at least for me, but I don't even know when you'll be watching this. It might be sunny outside, hopefully. I don't know. So 10 over x, remember, you could think of this as 10 times the mother function, 1 over x. We know that 1 over x looks like this. So that's going to be the general shape of 10 over x as well. So if you think about this weird situation here, thinking about that graph, I love that I can just zoom in on this. That's awesome. For whatever point you're looking at here, we're going to have two tangent lines that could be parallel to each other. So like those, for example, or maybe a little steeper like those, for example. But I could keep doing this all day long until the end of time, literally, because there are infinitely many that I could draw. Okay, that's getting messy. Look, I can zoom out really far too. Wow, I'm clearly so tired. So, how do we do this? Well, we want to be perpendicular to this function g. So you have to remember that a perpendicular line will have the opposite reciprocal slope. So flip the fraction, change the sign. So the slope that I'm looking for is going to be negative 5 halves. So if I take the derivative of 10 over x, first off, write it as 10 times x to the negative first. If I take the derivative of that, I'm going to get negative 10 over x squared. Check yourself that you get that as well, and that needs to equal negative 5 over 2. So what x value does that happen at? Well, think about this. If I multiplied by 2 over 2 right here, 2 times negative 5 is negative 10. 2 times 2 is 2 squared. Boom, right there. So my x value has to be 2. And I know the x value, so let's find the y value. So plug into your original function. Sorry, I hit the pause button. Plug into your original function. So f of 2 equals 10 over 2 equals 5. So I got the y value of my point. Y minus 5 equals my slope m, which is negative 5 halves times x minus 2. That is one equation. Remember, there are going to be two equations here. And if you're like, well, I don't know what else to do, remember the same thing here. I didn't really solve this equation like I normally would. But again, this 2 times 2 is going to give me 4. So my numerators are both negative 10. And so my denominators have to be equal as well. So I have x squared equals 4. So yes, 2 is one solution, but negative 2 quantity squared is also equal to 4. So I also have the x value of negative 2. So plug that into your function, and you will get negative 5 when you plug in negative 2 to your function. 10 over negative 2 is negative 5. So now we can write the equation y plus 5 equals negative 5 halves times x plus 2. So now compare these two equations and look at how cool that is. Today is the day of like, whoa, these problems are cool. But I'm totally going to stop now. Check yourself on the calculator, put them in slope-intercept form. I'm going to bed.